Trip 0 here, and we're going to go through how to create a smart sprinkler system. So this is probably one of the most important things to save time and money, is to get something to water your plants that's not going to require you to carry a hose everywhere. So this is actually kind of easy. It doesn't require a huge amount of expertise, a little bit of soldering, and a little bit of code writing, and that's it. So let's go through and build this out. First, this is the brains of the operation. This is the particle photon. This is what we'll be using to control the valve, open up the flow of water, and it's an internet connected device. You can see it breathing with that blue light. I've already provisioned this with the app on my phone that comes with the, you download the particle app from the Android App Store, and you provision the device and get it hooked up with your account and stuff, and get it connected to the internet. And once you've got it connected to the internet, you can program it with some logic, or you can use the logic already existing on the board, and maybe we'll take a look at that. But let's continue on how to build a smart irrigation system. So what will we need for this project? Here's actually the parts list. It's pretty short. You will need some wires and things, but other than that, this is the components list. What we have here, we've got a 12 volt normally closed half-inch solenoid valve. I got this on Amazon.com for about right around $20 or so. 12 volts, that's important. And with it, didn't come with it, but separately I got a half-inch NPT to half-inch barbed connector. This will attach to the hose, which will be the hose that goes to our water source. So there's that. This is the other piece this is the piece that connects to it, that will connect to the irrigation pipe that goes to our garden. And that's a half-inch NPT connector. It goes in right there. And this side is like 3/4 inch NPT. This is the 3/4 inch PVC adapter, and then 3/4 inch elbow. So that was that. Also on Amazon, Home Depot, just so you know where I got them. Relay, also got this on Amazon. It's a 5-volt powered relay. You use a 5-volt signal to power the thing up, and also a 5-volt signal to turn it on and off. So we'll be switching 12 volts. We'll be switching this on and off with that. Now, we need 12 volts. We also need 5 volts for this, 12 volts for this, 5 volts for this, and 5 volts also for the photon. So we need something to give us 5 volts. And that's this guy, just a simple linear regulator, 5-volt linear regulator that will take 12 volts and will output 5 volts and some heat. And then because the photon has a 3.3 volt signal, so we need something to convert that 3.3 signal to a 5-volt signal. That's what this guy does. I got this on Autofruit for like a little over $1 maybe. It's just a logic shifter that will shift something of lower voltage up to something higher. In this case, we'll use it to switch up 3 volts. It's a TI chip. I can't remember the model number. Let's see. It is S4A HCT125N. This little guy. It's 4-channel. We don't have 4. Maybe we'll have 2. Maybe some other things. So this is good. It's not bidirectional. It's only one direction. Anyway. So yeah, that's our parts list. And now we'll hook it up and write some code. Very few lines of code. So if I'll post the code on the blog as well. copy and paste it if you don't like coding or don't know how to code, and it should just work. So let's get building. Here we are, and we've got our prototype board, and let's start putting the components together. Particle photon, this is the logic level shifter power regulator right there. So let's first hook up the level shifter. We're just going to prototype some stuff out. This first pin down here is our power, so we'll hook that there, and this guy is our ground. So we'll just jump those there. Now to enable each of the gates, I guess we'll call them, to enable each of the shifters, we have to ground out the enable pin. I'm going to grab a yellow. Those seem to be long enough. So this pin right here, if I can get the light, there we go. Yep, this pin right here is our enable pin for the first shifter. So let's ground that, because we always want it enabled. Now we want to pick a digital output. These read D0 to D7, and D7 is also this little LED light. But we'll pick D2 because D0 and D1 are I2C, and we want to keep those available just in case. So we'll hook this up to our input pin and to D2, just like that. Now we want to take the output and bring it over to our relay. Which we will hook up down here. So let's plug in the output right up there and bring it all the way over here. Right there. Now we want to power the relay. And we'll hook up power right here to this pin. We'll keep the red rail as power. And then now we'll ground the relay. Let's see. See if I can, will that reach? It'll probably reach if I modify it a little bit. Make it stretch. Okay, so now we've got our relay right here, and what we can do to make this easier, these are the input pins, ground, power, and then our input 1. To make this real easy, we can just flip it and put it in so our pins match up just like this. There we go. Oh, we're not quite done. Let's hook up our ground and power to the let's hook that's a V in. Take that to the positive rail and ground to the blue rail. There we go. And we will, let's make positive to positive somewhere. Link the two rails so we can. Will that work? Will that reach? There we go. So we've got power rails linked. Let's ground the bottom one down here as well. I don't think we're using it, but let's do it just in case we do end up using it for something. Okay, that should be it. Take another look over everything, make sure everything looks proper. We are not hooking up this at the moment. We're going to power this thing by USB. Everything looks okay, so let's plug this into our USB power. That sounds interesting. So our relay's kind of going bonkers. Okay. Interesting. We may have to pull that down. Let me grab a 10K resistor. Magic resistors. I know one problem. This is not powered correctly. That's not the right pin. Okay. Let's try it now. Well, that's much better. So that pulls it down and actually turns it on. I don't know if you can, if I move this over, you can see it's turned on. I'm pulling it down. which actually is what we want, because D2 should be off. So we will keep that pull down resistor there. Let's write our code and upload it. All right, I think we're live. So we're going to code up right now our irrigation system. Once you go to build.particle.io, you will you can see this screen, and basically what you can do is create a new app. I've already got a bunch of apps and stuff. Create a new app. You give it a name. I've called mine Red Bed B because this is the Bed B's irrigation system. So let's get coding. This is the code that that it starts out with. So what we'll do, we need to set up our pins first of all. So pin mode. Let's create a couple constants first, and our irrigation pin is D3, D2. Well, let me double check. D2, yep. We skipped the first two, D0 and D1. Now we have two irrigation pin. We want to make this an output. Okay, and then we want to bring it high to start out with. And high basically means it's off. What we can do to make that a little more clear is we can create a define the relay's open when it's letting electricity through the relay. We will say that's low. And when it's closed, that means, so we want it to start out closed. Now, how do we make this internet enabled? Well, it's pretty easy. There's a particle function, and we give it a name. Let's call it water. And then we can pass it a callback to what function will be called over the cloud. So let's say that's also called water. We'll go up here and define water. Now, when we get this called, we've just associated this method, this function, with this cloud function name. So when this gets called, and if true is passed in, then we will open the relay. Otherwise, we will close the relay. If we get any other value other than true, we'll close it. But let's see, if we get let's make this make some events as well. Yeah, hang on. So we'll say open watering equals. If so, I usually make it so if you pass in blank value, it actually gets the value. It actually returns the current value. I'll show you in a second what I mean. So if it's I get a blank value, I want to return my status watering. And that'll either return a 1 if it's watering at the moment, or 0 if it's not. And then watering here down low, we will return the current state. Actually, watering equals. No, so we'll set watering and return the current watering. Pretty easy. Trying to think if there's anything else we need to do. Like this is the base. This is our whole program. It's the whole thing right there. There might not be anything else. So what we'll do is compile it, make sure it compiles. We will pick our device. I have all these devices. I don't see red bed, and it's probably because I need to. No, I need to refresh the page. So let's refresh the page real quick. There's red bed B. Make sure we've got that starred. It's online right now. And let's just burn it. Flash. Flash successful. Okay. So now that that's sharing, we'll turn off the screen share. You can see me briefly, and then we're gonna get up another window where we can turn this on and off. Here we go. I'm looking at our device. In fact, I can show you the device. Right there. So right now, this is the first time we've actually flashed this device, and you can see the purple light and white light, and it's all sorts of lights, green lights. It's actually probably updating the firmware. Oh, it just turned on. Awesome. So right now the relay's off because we've set it to high, and there's no light coming from down there, which indicates that it's closed. Okay, and now now let's turn it on. Let's see if I can mount this in a way that you can see it. Is that visible? Yeah, that'll work. So for breathing, and I'm gonna turn it on. Now I'm using a Python console to actually turn it on. There's easier ways to do it, but to use the Python console, I have to log in basically, and I don't want to type my username and password on the live video. That would be kind of awkward. So what I'll do is I'll just activate this. So red bed B, water true. And we have the red light. Now let's pass in just a T, and that turns it off. We can pass in false, it'll still be off. Pass in true again. And you pass in nothing, then it just returns. Pretty awesome. Okay, well that's it. So that was the coding part of our how to make a smart irrigation system. And hope that was interesting. So what I'm going to do is I'm going to take this board and put it on a real breadboard, put it in a case, hook up the power regulator to it, and then install it in the red house. All right, catch you later.